This is lesson 7.4. We're going to start on this chart and we're going to just pick all the properties that apply to parallelograms. We're going to learn about these other three shapes today. But the things that are true in parallelograms, we know that both pairs of opposite sides are parallel in a parallelogram. We know that the consecutive angles are supplementary in a parallelogram. We know that the opposite sides are congruent, the opposite angles are congruent, and the diagonals bisect each other. But all the sides don't have to be the same, all the angles don't have to be the same, the diagonals don't have to be the same, the diagonals don't have to be perpendicular, and the diagonals don't have to cut any angles in half. So really, it's just these first 5 properties are always going to be properties of a parallelogram. For our next 3 shapes, though, the definition of a rhombus is a parallelogram with all 4 sides congruent. So a rhombus is a type of parallelogram, but it has the extra identity of having all 4 sides congruent. A rectangle is a parallelogram with all 4 angles congruent. And then a square is a parallelogram with all 4 sides and all 4 angles congruent. So if we look at it more as a Venn diagram, everything on this page is quadrilateral. Everything on this page is a parallelogram. This shape here is only a parallelogram, whereas this shape here is a rhombus and a parallelogram. This shape here is a rectangle and a parallelogram. This shape here is a rhombus, it's a rectangle, it's a parallelogram, but it's also a square. So this would have the properties of any of the other shapes. The rhombus would not have the properties of a rectangle, but it would have the properties of a parallelogram. The rectangle would not have the properties of a rhombus, but it would have the properties of parallelogram. So there are going to be a lot of scenarios of always, sometimes, and never, like a rectangle is sometimes a rhombus because you could see that they overlap here. A square is always a rectangle because every bit of that square part is in the rectangle part, and things like that. So if we go back to our chart, anything that was called a parallelogram, like the rectangle, the rhombus, and the square, have the same properties that that parallelogram does. So I could add check marks for all of them here. But now we have the definitions. So all sides congruent was true for a rhombus and a square. All angles congruent was true for a rectangle and a square. In example 1, PQRS is a rhombus. What is the value of y? So we just learned that a rhombus has all the sides the same, so I could set 5y minus 6 equal to 2y plus 3. So we get 3y equals 9 and y equals 3. So for this one, they want you to classify it and find the value of x. If you'd like to pause now and give it a try, the answers are posted online. Some additional properties. So the diagonals in a rectangle and a square are congruent. So not only do they cut each other in half, but they're also all the same length. And then for the rhombus and the square, the diagonals are perpendicular, so they intersect at a right angle, and each of those opposite angles is bisected. So the 2 angles here at B match the 2 angles here at D, the 2 at A match the 2 at C. So that means we can add a few more checks to our thing. Diagonals are congruent. We just said that is true in a rectangle and a square. Diagonals are perpendicular was true in a rhombus and a square, and they bisect the opposite angles in a rhombus and a square. Example 2, DEFG is a rectangle. They're giving me the length of FD and the length of EG. So if I look at the letters here, D, E, F, G, they're giving me FD and EG. They're telling me the diagonals. And in rectangles, those are congruent. So I could set 3x minus 7 equal to x plus 5 and get x is 6. And if we want to find EG, we're going to plug 6 in there. So EG would equal 11. In our next example, even though it's not drawn to look like it, they're telling me that DKLM is a square. We want to find the value of x if the measure of angle KAL, so this one in this corner, is 2x minus 8. All squares have diagonals that are perpendicular, so that angle equals 90. So 2x minus 8 equals 90. So 2x equals 98, and x is 49. So here's try 3. It can be a tricky one. I would recommend giving it a shot. Answers are posted online. So here's some of those always, sometimes, and never problems that I had mentioned. So it helps to either think about the base definition of what they're saying, or there's no great way to describe how to do these. Here, a rhombus is defined as a figure with 4 congruent sides, a parallelogram with 4 congruent sides. And this rectangle was a parallelogram with 4 congruent angles. So can we think of a shape that has 4 congruent sides and has 4 congruent angles? Yes, we can think of the square. Can we think of a shape that has 4 congruent sides but does not have 4 congruent angles? Yes, we can, a rhombus. So because I can imagine it in both ways, I can imagine one scenario where it is true, and I could also imagine another scenario where it isn't. That answer would be sometimes. For the next one, we have a parallelogram with 4 congruent angles, and here we just have a parallelogram. So can you have a parallelogram with 4 congruent angles that's considered a parallelogram? Yes. Can you have a parallelogram with 4 congruent angles that's not a parallelogram? No. Every single one of these parallelograms with 4 congruent angles is also going to be called a parallelogram. So if I cannot think of a way that it doesn't work, that's always. If I wasn't able to think of a way that it did work, that would have been never. All right, the main part, the part that I like the best about this section is proving which shape it is on the coordinate plane. And this is going to be similar to how we proved whether a quadrilateral was a parallelogram, but we're going to take it a step further. Instead of just doing 4 slopes or 4 distances or 2 slopes and 2 distances, we're going to do all 4 slopes and all 4 distances. So the slopes, remember, tell us if we have right angles. It tells us if we have consecutive sides being perpendicular, which tells us if opposite sides are parallel. So we're going to look for the consecutive sides being perpendicular or not to determine if our shapes have right angles. In a parallelogram, there's no right angles. So that is going to be consecutive sides, not perpendicular. A rhombus also does not have right angles. So consecutive sides, not perpendicular. But the rectangle and the square do have right angles, so these we would say that the consecutive sides are perpendicular. So the distances, we're checking to see if they're congruent or no. And we're looking to see if all of the sides are congruent, because if it's a type of parallelogram, at least the opposite side should be congruent. But if it's going to be, say, a square or a rhombus, then all sides need to be congruent. I can't write the word sides. Sides congruent. So that means in the parallelogram and rectangle, all sides not congruent. And these are 4 different descriptions. Right? This one was not and not, this one was and not, this one not and was, this one was and was. So as long as we can find the answers to those 2 questions, we can figure out exactly what shape that it is. So in the first examples that we're going to look at with these, the chart is already done for us. They found all the slopes, they found all the distances, they reduced everything, and now we're going to look at it to determine what shape we think it is. So the first thing I'm going to check, always a quick check. We don't have to make a note of it, but it is good to check because eventually we're going to have shapes that are not parallelograms. I have a pair that's parallel here, and I have a pair that's parallel here, right? AB is 2/3, CD is 2/3, BC is negative 2/3, DA is negative 2/3. So we know it's a type of parallelogram. So now we're going to look at whether we have perpendicular. So looking at consecutive sides, one side right after the other. Are these the opposite sign and reciprocals? They are the opposite sign, but they're not reciprocals. So we're going to say consecutive sides not perpendicular, which means I can already eliminate the square and the rectangle because those were the ones that did have right angles. So now it's either going to be a parallelogram or a rhombus. So I'm going to check my distances. Are all sides congruent? No. All sides not congruent. So that means it's not a rhombus. It is just going to be considered a parallelogram. I'm not going to write the word because it's too long. For part 2 here, again, we'll start with the first question of, are our consecutive sides perpendicular? Is -8 the opposite sign reciprocal of +1/8? And yes, it is. So we can start with consecutive sides are perpendicular, which means this is either a square or a rectangle. So if I look at all the distances, they're all the same. So all sides congruent. So I do have all the sides the same, and it has right angles. That would make this shape a square. Forgot to check, right? -8, -8 matched, 1/8 and 1/8 matched. So we were okay there. And then the third one, the -3/4 matched, the 4/3 matched. We know it is a type of parallelogram. My consecutive sides are perpendicular because -3/4 and +4/3 are opposite sign reciprocals. When I look at my distances, they are not all the same. So all sides not congruent. So it has right angles, but all sides are not the same. That would be a rectangle. So here's one for you to try. The chart is already made. Answers are posted online. But of course, we're not always going to give you the chart. You're going to have to make it yourself. So we're going to find the slopes and distances and then determine what type of figure this is. So let's start with our slopes. We're going to do 9 minus 2 over 1 minus 5, 7 over -4. QR, we're going to do 2 minus 9 and -3 minus 1. So we get 7/4. For RS, we have -5 minus 2 and 1 minus -3. -7 over 4. And then for SP, we have 2 minus -5 and 5 minus 1. So I have -7/4, -7/4, 7/4, 7/4. It is a type of parallelogram. We do have two pairs of opposite sides parallel. So we're going to check, do we have consecutive sides perpendicular? So -7/4 and +7/4 are opposite signs, but not reciprocals. So consecutive sides not perpendicular. And now for my distances, I'm going to do my sneaky shortcut, the unsimplified version of each one, which isn't really going to matter because all we changed are signs on this one. We didn't change any numbers. We're going to plug those into the distance formula. And even though most of you are probably looking at this and saying, oh my gosh, they're all the same numbers, of course they're going to be the same. This is still a proof. So we're still going to show those steps. So that's 7 squared and -4 squared, 49 and 16. Takes the square root of 65. As long as you show me what you plugged in, if you go straight to the answer, I'm okay with that because I still saw the work that you did to plug it in. So if you wrote it like this, I'm fine with that, with you skipping that step in the middle. Again, these are proofs, even though they're coordinate proofs, so we have to show that work. Oh, edge, nobody wants you. Okay. Equals square root of 65 and 7 squared plus 4 squared square root of 65. So looking at these, all sides congruent. So I don't have right angles, but I do have all sides are the same. This would be a rhombus. Everything you see here would be required for full credit for this problem. So here's the final one for you to try. Answers are posted online, and that is the end of section 7.4.